In this video, I'm going to show you how to calculate average reliability, also referred to as Cronbach's alpha. So we go up to Analyze, Scale, and select Reliability Analysis. And once we get in there, this window shows us all the items that are in there. And note that the way that I label my items, there is a variable name and then sort of the gist of what it means. And I find that really easy to use because then you can identify which items you want very quickly. Okay, so we're going to go down and find our job turnover items. There's number 1, number 2. And you'll see here that I wrote C reverse item for job turnover 3. And I did that to remind myself not to use the original item, but to use the reverse coded or recoded version, which is right below it. And we'll put that in there. We're going to now go to the statistics button and select descriptives for item, scale, and scale if item deleted. There's some other things that you can do, but for today we're just going to leave it at that. Hit continue. And now we're going to come down here to scale label, and we're going to type in job turnover intentions. And this is helpful if you're doing a lot of reliabilities. You want to be able to look at your output and easily identify which output refers to which scale. So we're going to click paste. And I always do that to keep track of what I'm doing. Another nice thing that you can do with this is you can copy it and paste it below. And then you can use it as a template to adjust what you're doing. So in this example, what I'm going to do is show you what happens if you leave that original non-reverse coded item for job turnover 3 in there. And we'll change the scale name, job turnover intentions with original JTO3, and then we're going to run the syntax. Okay, so it only did the first one. To go back, must have been where my cursor was, so we'll select all of it. Do that again. So as you can tell, the scale name here easily shows us which scale we're looking at. We'll start with the one we wanted. Job turnover intentions. We have 133 cases. Cronbach's alpha is 0.829. That's good. We want it to be above 0.70 because an R squared of 0.70 would be 0.49, representing explained variance of about 50%. So we want it to be over that. The other thing to keep in mind with Cronbach's alpha is that it is an average reliability, so it assumes that each of the items contributes equally to the total score, which may or may not be the case. Okay, we've got item statistics, mean and standard deviation. We have our item total statistics, and I'll highlight the Cronbach's alpha if item deleted, which can help you identify strong and weak items in your scale. For example, here we have 0.812. If you take out job turnover 2, alpha will improve a little bit. But if you look at the average reliability here, it's highest when you have all 3 items in the scale. So now we'll go down to our other scale, job turnover intentions with the original item that was not reverse coded. And you can see that Cronbach's alpha is negative, and we get a warning. And SPSS is trying to tell us, hey, wait, maybe you did something wrong. And the value is negative due to a negative average covariance among the items, which violates assumptions. And this is logical because the original item was I want to remain in my job. So a high score would mean that you have a low intent to leave. So that's why we need to flip it before we put those items together. Okay, so that is it for this little tutorial, and I hope that helps you calculate Cronbach's alpha. Thanks a bunch.